Hello everyone, in this video I'll be talking about balancing chemical equations and how we can write relationships using balanced equation. Chemical equations are concise representations of chemical reactions. As we can see, when we have two hydrogen molecules with one oxygen to produce two molecules of water. So on the left hand side, here we have the reactants. They appear on the left hand side and the products appear on the right hand side. The arrow here separates the products from the reactants from the products. States of the reactants and products are written right to each of the compound. For instance, we have hydrogen here to be gas, oxygen here gas, and this is gas. So we have the states of reactants written in parentheses, and S is for solid, G is for gas, L is for liquid, and AQ is for aqueous. Coefficients are inserted into the balanced equation to follow the law of conservation of mass. The law of conservation of mass says in any chemical reaction, mass is neither created nor destroyed. Mass is neither created nor destroyed. So that implies that all the number of atoms that we have in the reactants must be equal to what we have in the product. Let's take a look at the example on how we balance this equation. For this equation, we have carbon in the reactant, hydrogen in the reactant, and oxygen in the reactant. I would like to use a line to separate our products from our reactants. So if we have carbon, hydrogen, and oxygen in the reactant, automatically we should have carbon, hydrogen, and oxygen in our products. Because we want to make sure that we follow the law of conservation of mass, so whatever number of atoms of carbon, hydrogen, and oxygen we have in the reactant must be equal to what we have in the product. Here we have one carbon atom, hydrogen is 4, oxygen is 2. In this place we have 1 for carbon, 2 for hydrogen, and 3 for oxygen. This 3 is resulting from the fact that we have 2 of oxygen in this place and plus 1 of oxygen in water. So we can see that this equation obviously is unbalanced because hydrogen is 4 here and is 2 here. Oxygen, we have 2 here and 3 here. So what we need to do is to make sure that we add or increase the coefficients to make sure that all the numbers of atoms are balanced. Whenever we are trying to do this, we should make sure that we do not change the subscripts. We do not change the subscripts. The subscripts we have here. For instance, we cannot say because we want to increase the number of oxygen in CO2 and we change 2 to 3, right? That is not possible, right? That is wrong. So I'm going to start with hydrogen because I have two atoms of hydrogen here. I want to make sure it is equal to what I have on the reactant. So I'm going to multiply this by 2. So that gives me 4. And this 2, I'm going to bring it up to where I have my hydrogen and I put it here as 2. So that has increased my hydrogen to 4. The next thing I do is because my hydrogen has increased to 4, hydrogen as the number of hydrogen has affected my oxygen because they are together. My oxygen in the product is now 2 plus 2, that is 4. So I have 4. Now what do? I'm going to make sure that my 4 atoms of oxygen is equal to what I have here. I multiply this by 2, that gives me 4. Then I take these 2 and place here. Fortunately, our oxygen does not have any order, it's standing alone. So all the atoms are balanced, and this represents the balanced equation. Let's go to another example here, the same thing. I'm going to separate that. I have K, S, and O, oxygen. I have Ba, and I have Cl. So all other things equal, I should have K, S, O, Ba, and Cl. Here I have 2, 1, 4, 1, and 2. Here I have 1, 1, 4, 1, and 1. So we can see obviously that this is not balanced, so I can do multiply this one by 2 to make sure that I have 2. So I bring this up here, that becomes that. So the next thing is, because I have 2 here, my chlorine has increased to 2. So I'm going to change this and make it 2. And already I have 2 here, so it is balanced, everything is balanced. So that brings us to a balanced equation for this guy. The next one I want to talk about is this. For this, because there are many ways we can do this. We can write NaCO, carbon, oxygen, and do that. But because this is a polyatomic ion, I have 2 polyatomic ions here, which are carbonates and nitrates. We can decide not to separate them because carbonate is appearing as carbonate in the reactant and is same, not changed in the product. Nitrate is appearing as nitrate here, and here it is not separated, like we do not have nitrate here, and we have nitrogen and oxygen separately here. So I would like to leave them and treat them as one. So I'm going to say I have NaCO3 and potassium and NO3. So likewise, I can say NaCO3, potassium, and CO3. My Na is 2, CO3 is 1, potassium is 1, nitrate is 1. Here, Na is 1, carbonate is 1, potassium is 2, and my this is nitrates. 9A NO3, NO3, CO3. CO3 is 1. So sodium is 2, so I can multiply this by 2 to give me 2. And I bring this 2 here. And potassium is this has increased my nitrate to 2. So this is going to be equal to 2. Now I have nitrate to be 2 here and 2 there. But nitrate here is 1. So I'm going to multiply my nitrate with 2 to give me 2. And I bring this this 2 up here. So this has changed my potassium to be 2. And potassium is now 2. And I already have 2 atoms of potassium in my product. So this equation is balanced. We have 1 mole of sodium carbonate with 2 moles of potassium nitrate to give 2 moles of sodium nitrate and 1 mole of potassium carbonate. We can balance this equation. After this balanced equation, we can write relationships. to predict whatever we want to predict or estimate in our chemical equation. But before we do that, we have to be sure that our equation is balanced. So before we can predict, we need to know how to write relationships. So I want to show how we can write relationship. We can pick any of the two compounds here and we write our relationship. For instance, I want to pick CH4 and CO2. To write a relationship for this, I'm going to say I have 1 mole of CH4 equals to 1 mole of CO2. If I pick this and this, it's going to give me 2 moles of oxygen equals 1 mole of CO2. We can just pick any of the two compounds and write as many relationships as we can write. So we can use this relationship from balanced equation to predict products or reactions that we want to do. For example, the question can be how many moles of CO2 can be produced from 8 moles of oxygen. So, in this case, what we need to do is to find out what the relationship that is appropriate to solve our equation. So for this, the question is asking us for the moles of CO2 that can be produced from oxygen. So we need to write just a relationship between oxygen and CO2. We look at the balanced equation. Our relationship is going to be 2 moles of oxygen equals to 1 mole of CO2. So we use that to predict the moles of products that we want. So it's going to be, our given is 8 moles of oxygen. So we have 8 moles of oxygen times, from this relationship, we are looking for moles of CO2. Going to be 1 mole CO2 over 2 moles oxygen. 2 moles of oxygen. And we can cross this out, right? And it's going to be 8 times 1 divided by 2. So that gives us 4 moles of CO2. It means that from this equation, if we increase the moles of our oxygen from 2 to 8, we're going to get 4 moles of CO2 as the product. So this is how we use balanced equation to write relationship and to be able to predict whatever outcome that we need to do. I hope this helps us in solving math problems. Thanks for watching.